All right, welcome, ladies and gentlemen, to week number 42, Open Q&A. My name is Mr. McLaughlin, and I am here to answer your questions. And I also wanted to kind of take a step back and just kind of check in and see how everything is going with you guys. I did a, kind of community post to see how everyone was kind of doing with this distance and online learning. And I think it's amazing, no matter, I can't even think about a time that I can remember where I feel like anybody around the world all has kind of like shared a common like experience. We're all going through this, and it's interesting to see, different countries, different school districts, different states, and everybody has a different, kind of experience, and everybody's kind of handling this differently. But we all have this, kind of in common, this trying to teach and trying to learn in this kind of environment. And I think it's a really interesting kind of idea when I really kind of step back and I'm looking at, I have people from all over the world, that check into these live streams or that watch these videos or that responded to the poll. And actually, I didn't even pull up the poll here. I kind of want to see. I'm not sure if you guys can see. I can go ahead and pull up. I think it's been a while since I pulled up the poll. But what I can do is, go ahead and take a look. I looked at it the last couple of days, but I haven't pulled up the poll recently to kind of see where everything was going with you guys. So let me go ahead and take a look here. And I'm actually going to be interested to kind of see how it pulled up. But from what I remember, a lot of students were struggling, but they were beginning to kind of figure things out in their end. I think it's difficult. They're having trouble understanding, getting it really into the rhythm routine. Not everybody was back into the classroom. My school is back 100% now. We're still wearing masks. We have dividers and everything like that. And we have students that are out on quarantine. And, so that's just kind of like now our regular occurrence. But it's difficult, because I have to provide extra instruction for those students. They have extra work now, trying to keep up with all the classes. We do have an online platform that we were using because we did start the year in a hybrid environment, which wasn't bad. I think it got the job done for what it needed to do. But yeah, I think there's a big difference between ending the year like we did last year for those of us that are on the same school schedule. As far as ending the year, kind of in March and just kind of going through the end to now like beginning the year and trying to get students that were caught up that maybe, struggled in general from last year. And then trying to, start again a new year with this online learning, because I can tell you guys for once, if you've been following my channel, math was not my forte when I was growing up. So this idea of trying to learn online, especially math, would not have been something that I would have been very good at by any means. So, I can definitely understand a lot of the frustrations that a lot of you have with, trying to learn a concept, especially like math, where I think it's important to have that kind of interaction with your teacher, interaction with your peers, where you can kind of have that real-time interaction and conversation with them about the math, about what you're learning, to ask those kind of questions, that those, like, I love those, we call them like the stupid questions, like, hey, where'd you get that? Or what'd you do? Because not always are you going to be able to connect the dots as quickly as maybe the teacher is, expecting you to, or, maybe for me, my mind would always race off, and then I'd just be like, come back and be like, oh, what just happened? And then I try to like go back and try to figure things out. So, I wanted to make sure that we just kind of took a step back and, allowed you guys some opportunity. I have 193 comments. I haven't gotten through all of them. I've only kind of checked a couple on my phone. And I also sent out an email to just kind of reach out to you guys, kind of see how everything is going. I will go through this chat. So please, feel free to add it to the chat, guys. Just kind of let me know, where everything is kind of standing with you. Are you back full time? Are you in the hybrid environment? Feel free to go ahead and add into the chat. And I'd love to just kind of see where you guys are, as well as like where you are in the world as far as, how this schooling is back. I know that some people are, haven't even been back in the classroom yet. I can tell you there was a big sense of relief as far as being a teacher, even with the difficulties of the, going back to school and, with, being now exposed more, but it was just so nice to actually be able to teach and not have to be talking to a screen. Like I do this once a week, so it's not that bad. But when I was doing this digital learning, like 5, 6 6 hours a day, it was very exhausting, very exhausting. And I can, imagine too, is like, as far as students, like, how are you guys holding up with that? Looking up at a screen and trying to learn from your teachers. I know it's difficult on the teachers trying to come up, trying to be engaging behind a screen when you're just, you don't get that natural interaction. And I think that's one of the more difficult things that I've found as far as a teacher. There's nothing wrong with teaching a concept. If you guys, you guys submit questions, we're going to get through these questions in a second. I think I have 13, but it's kind of, I can teach you how to do a problem very quickly and I can give you the answer, but like the dynamic of being inside of a classroom and that teaching and that flow, I think is something that's so important to the learning experience that you're just not going to get behind a screen. And so I know it's been very difficult for those of you that are doing the hybrid. Maybe you're still always, completely online. You're missing that natural interaction, that natural discourse between you and the teacher. So just want to kind of check in for the chat. Online, Gabriella says she's online 7 days a week. Wow. Let's see. I'm in hybrid and then taking AP. Yeah. PSX, I can only imagine with like the AP curriculum. I mean, that's just like even another step up, right? Definitely crazy. Oh, I'm glad my videos are helping out. Hi, teacher, could you help me? Again, guys, I do have in all the questions. If you guys want to submit any questions that we will be coming up, that will be in my, that will be in the, all my questions are in the description. So if you guys want to go ahead and submit any questions, you guys can go and do that. Your reason I'm not failing. Well, I'm glad I can do whatever part I have for you guys. My school is still in hybrid. Yeah, I've seen like a lot of people are still in hybrid. I was actually surprised. I don't know. I'm in Florida and they just kind of opened everything up down here. So, but it seems like a lot of students are still like in the hybrid or in completely digital. Wow, taking. Yeah, the AP videos, I've heard of the AP videos on the AP classroom are really, really good. And so I definitely still follow a lot with that. So I'm glad they made that because, I think when you're pushing, when you have something like an AP curriculum and you're really, it's everybody is expected to know the same material on the same date. You got to be able to provide something for everybody since, all these schools and all, everybody's getting this different experience, because the different schools are deciding when to go back. Everybody's like teachers, like you got to be able to provide everybody an equal opportunity or at least as equal of an opportunity as you possibly can to do well on that AP exam, because otherwise there's just too many disparities, across income level and across locations. And, that I'm really happy that they went through that. They started those last year and got those going. And I've heard some really good things from there. 30 cases. Wow. Oh, okay. So you went back and then went back to hybrid. Yeah, I think the hybrid, I don't think we had any cases when we did the hybrid. So it was pretty good from on there. But, some other things I just wanted to, check in with you guys, as far as like, I know it's been hard, like missing class. I think it's great that we've, incorporated a lot of ideas for when you miss class. A lot of the instructions going online, which it was always there, but I don't think we ever took advantage of it because we didn't really have to. There was a lot of since I've been in education, at least the last like maybe 5 years. There's been a lot of like companies, a lot of software and websites that have tried to incorporate us to like go online. And, there's just really never been that sense of like have to fully rely on online instruction or an online database. And then sure enough, COVID happens and it's like, now we need to rely on all this. So I think there's definitely going to be, because it doesn't make sense. There's no reason that if we can't be in school that you cannot get instruction. I don't think that's the saving grace. It's not going to replace the in-person instruction, but there's no reason that you cannot be away from your classroom. And, the one thing one of the reasons why I started doing online lessons is the absolute thing I hate the most is, a student will miss my class and it's like, what did we miss? What did we do? And I'm like, well, I don't have time to spend 45 minutes reteaching the lesson or going over everything. And so that was like the immediately, the thought in my mind is like, why shouldn't this student have access to what we covered? if they miss class or if they're out sick, it's students are in the hospital for like weeks or like whatever. Like they should have access to everybody just like inside the classroom. I think it's my job as a teacher to make my class as engaging and as exciting so that they want to be inside the classroom. But therefore, if they are unable to get to there, they still should be able to receive the same education that anybody that is inside the classroom, if they're not. But I know it's been hard, guys, definitely with grades, testing. I think there's just stress. I think it's been difficult, for me, just as far as like seeing people, it's just kind of weird. And I was thinking, actually, one thing I didn't write down, but one thing, I think the one thing we take for granted, I was looking at some students earlier and I saw their face and I was like, and if you guys follow my stories on YouTube, you'll see that I showed a picture of me covered and then I covered my face covering. And then I took a picture of me without my face covering. And it was crazy because, obviously if you're watching my videos, you're probably used to my face, but some of these students, I've never seen their mouth and nose. It was so crazy. I've never seen their mouth and nose. And then like a couple of kids, they were like taking a drink of water. So they pulled down their mask and I was like, oh my God, you look completely different than the way that I thought you would, And it's so weird. It's like we take for granted, and rightfully so, just the idea of like the facial features of people and how much that can impact them. And I think also like just the idea of like touch and seeing people, not so much like, touching their like shoulders, but just like handshakes, when you meet, seeing like my older students, coming to my classroom and like shaking their hand, and stuff like that. It's like, I don't know. It's this weird kind of feeling. And I think it just kind of changes that mentality that you have inside of the classroom. And, it's been tough, even as me as a teacher, kind of hold up. So I know it's been tough for you guys. So that's why I wanted to check in. Feel free. There's a lot of output, a lot of support guys that I've added in for you. If you're on my email list, you can reply to that email. I'll be checking all my emails and I, try to respond as much as I can, guys. But, obviously things get very busy. I got grades. I got, what do I have? Oh, I have quizzes I got to grade tonight and tomorrow morning before school. So, all right. So that's probably means I should probably get going, right? Hey, Addie, good to see you in here. And Julia, thank you. Well, I don't really mean to be inspiring, but I just like to, I like to kind of look at this as I don't know, sometimes, I do math problems, right? I'm going to do math problems for the next 30 minutes. And I'm like, you know what? I like to stake this time and just to kind of talk to you guys here who's on the chat. What's up, Miss Chicken? Well, hello. Happy Elp 99.9. Can you make a video about graphing absolute value equations? Mohammed, if you couldn't just go ahead and submit when you guys do have questions. I don't have time to take questions off of the chat because Emily, this is live. But I did take some questions off of my Google form. So if you guys have questions that you'd like me to cover on my next stream, just go to my Google form inside the description for this live stream. If you are looking for some little bit meaty answers, you can go ahead to my Discord, which is also there. And then just remember, guys, that is a community. So it's not just about you posting your answers and hoping that somebody's going to answer them for you, but it's about you really interacting with others, helping other students with their questions. So therefore you and them can have a better understanding of the math. It's not just about help me, but it's like, what can you also do for other people to help them out? Yeah, I think, learning proofs, you really just got to work through the break. You have pressed it. I'm like, well, awesome. 5 in the morning, UAE. Wow. Well, hey, Juan, Addie. All right. What's up, mate? Good day. All right. Oh, physics 1, man. Jeez, I can. All right. So let's go ahead and get in. Can you explain phase shift in a sine and cosine functions? Okay. So I really don't like the first. So 2 questions? Yeah, 2 questions. I'm like, I'll try to do my best. I usually typically like to have something a little bit more concrete, what I need, what I'm going to be talking about. So I'm not really sure where your trouble is. If you're not understanding like what to do, where to go. But so I'll try to do my best. So anyways, guys, again, I'm going to kind of get started on the math questions now. If you guys do have any questions though throughout the stream, feel free to add them in to the Google form, but I'm not going to be able to take any questions. Then we'll see how long it does take me to go through the stream. Oh, one thing I forgot to mention, I think I mentioned it last stream, but I wanted to let you guys know that a couple cool things are coming up. One, Thank you to my members of my YouTube channel, because with their support, I am now able to take these live streams and I have them timestamped. So if you missed my live stream, but you submit a question, you want to see if I answered your question, you can always go down into the description below. And if you ever find one of my live streams on like being suggested to you, you know, by the YouTube algorithm, you can always just go ahead and take a look at the description, see what questions I answer, and then if anything you really care to see or need help with, you can go ahead and watch them from there. So I'm really excited about that. So far I've done 41 live streams that I have been able to add the timestamps to the questions. So that's like, you know, roughly 410 questions that I have. And I'm looking into doing something where I can add all the timestamps into like a document or something where it'd be searchable. I don't have that feature yet, but that is something that I am looking into. So we'll see how that goes. But anyways, yeah, just want to let you guys know, because, you know, otherwise when you see it like a live stream and it's an hour long, it's like, what else, you know, I'm not going to watch this live stream, or, you know, even if you just want to see if I answered your question, you know, you probably don't want to like watch 40 minutes of math problems just for your one question. So I did add the timestamp so that can hopefully make things a little bit quicker for you guys. And again, thank you to the YouTube members for making that possible. And then the other thing I want to let you guys know, for those of you that are taking exams, I will be unveiling some more content for semester exams. So I do have some new semester exams that I have created, some semester exams review, and a kind of like a little mini course that I'm going to be working in with some online instruction that we'll be doing. So kind of like these, you know, I used to, like in my class, we'd sometimes do like the, you know, study sessions. Yeah, basically like a study session on the weekends. So that's something that I'm going to be offering out for you guys. It's only for pre-calculus students. So if that's something that you are taking pre-calculus and you're not currently in my course, obviously the students in my course will have access to it. But then for anybody that's not in my course, but that would like to go ahead and join the things, I'll have some more information on that coming up. So all right, let's get into the math. Again, if you are just getting in, you have questions, please feel free to submit them into the chat. Oh, I'm sorry, not in the chat. Don't submit them in the chat. Well, you can, and hopefully maybe some people can help you guys out as well. But if you want me to answer your questions, go ahead and go to the Google form and I'll get to them. All right, I am chit-chatting away. It's probably that second cup of coffee I had midday. I gotta slow it down. It's always bad. All right, so let's do some math problems. So it says, can you explain phase shift? Yeah, the phase shift is basically the horizontal shift. It doesn't matter if it is like y equals x minus 2 quantity squared, right? Like that's going to be right 2, okay? So if I had y equals, let's just say cosine of x minus pi, okay, that's going to be right pi. Or sometimes we'll just say a phase shift, you know, of pi, you know, to the right, or just of pi. Like there's a couple different ways we can go ahead and figure this, but the phase shift is basically how you're shifting to the left and to the right. And that's basically, it doesn't matter if it's for cosine, doesn't matter if it's for sine. The only thing I will say that's very important to understand is if you had like y equals 2, not this one. If you had a 2x minus 2 squared, this is not 2 to the right. What we need to do is we need to put it into this form, we need to factor out the 2 quantity squared. And this form is y equals a, let's forget about this. When that happens. Yeah, you have the b, but I'm not worried about the b times x minus c squared, okay? So if you're gonna be identifying the c and you have a b, you gotta make sure you factor out that b, all right? Because what's happening is this b is what we call a horizontal compression of 2 and going right 1, all right? So the reason why this is important is, let's say I change this problem to, you know, y equals the cosine of 2x minus pi. Well, this is not pi to the right. We need to do is factor out this 2. And so this gives us a cosine of 2 times x minus pi halves. Okay, so now you can see that we have a horizontal compression of 2 and the graph is being shifted to the right 2. Now, how do we know it's a horizontal compression? Or right to pi halves, I'm sorry. Well, again, hopefully you understand from the quadratic, we talked about the vertical stretch and compression, then we got the horizontal stretch and compression. But the nice thing about the, you know, trigonometric functions is, I don't know why I have this y here. The period, remember, is the distance it takes the graph to repeat itself. So the period is going to be 2 pi divided by b. Well, in this case, my b is 1, so it's just 2 pi. But in this case, if I take 2 pi divided by 2, that equals pi. So the distance that takes the graph to repeat itself is 2 pi. But now when I have a 2 in front of that x, the distance it takes to repeat itself is pi. So sure, you can see that period is being compressed. And also it changes that horizontal shift. So that's, hopefully that helped you out. I hate answering questions where I don't really know what the student is needing help with, but hopefully that helped out. The next one is I need help with parentheses and brackets. Again, I don't know, so let's just make up a problem and I guess see what happens here. So parentheses and brackets, all they are grouping symbols, okay? And the idea of grouping symbols is for me to kind of tell you what I want you to do in a certain order, right? We follow these order of operations. So I'm just going to give you guys a common problem. So 2 times 1, plus 3, I'm just going to make something up, divided by 3 minus 5. Okay? So, typically, if we were going to follow the order of operations, we're going to apply multiplication and division from left to right, right? So that's what we would do first. So we do 2, plus 3 divided by 3 is going to be 1 minus 5. And then you'd work addition and subtraction from left to right. So 2 plus 1 is 3, minus 5 is going to be a negative 2. Okay. Now, what if I wanted to, say, hey, well, there's actually some operations I want you to apply first before you go ahead and do all of that. That is basically what this is allowing us. That's basically what the grouping symbols allow us to do. It doesn't matter if it's a parenthesis or if it's a bracket. And so what we could do is do something like this. I could say, all right, well, 2, what if I wanted to add the 1 and the 3 first? So I'd say 1 plus 3. And then divide by 3. And then let's say I wanted to do these two first, minus 5. Okay. So again, you do inside the parentheses first, right? So what that does is that changes your order of operations because the order of operations has us do inside the parentheses first. And again, you could even do a bracket too. Okay. Ooh, it makes things even really fun. Let's see what this answer is. So now what we're going to do is we're going to simplify everything inside the parentheses first, then simplify those two by the division, then simplify the bracket, and then we'll multiply by 2. So it's kind of like working from the inside going out. So I don't know. Let's just go and see. Let's see if we get negative 2. So 1 plus 3 is going to be 4 divided by 3 minus 5 is going to be a negative 2. Okay. 4 divided by negative 2 is negative 2. So 2 times a negative 2, and that's going to equal a negative 4. So you can see we're getting a completely different result, right? So that's what the order of operation just lets us do. It just allows us to more control on to tell the user or whoever's completing the problem which operations we want to apply before others. Otherwise, we would default to our accepted order of operations. Question number 3 says, find the possible rational roots of the polynomial. Determine the real roots. I'm not going to determine the real roots, but I will tell you what to do. So what the question is asking is for the rational zero test. And for the rational zero test, all we're simply going to do is to find the list of possible rational zeros. So the rational zero test does not tell you what the rational zeros are. What it does tell you is what is possible. If there is a rational zero, it's going to come from this set of numbers. Okay. Now, what I would do is when I used to teach this with finding the zeros, I would use the calculator. And I'm not going to use the calculator for this question, so I'll set it up and then I'll tell you what you could do. You could use the remainder theorem as well. But anyways, all we're simply going to do is this is going to be what we call our P, and this will be represented as our Q. Okay, so the rational zero test, which is the possible rational zeros, so the possible rational zeros is plus or minus the factors of P over Q. Okay, so let's go and take a look at them. Plus or minus, I'm going to use parentheses so I don't have to write plus or minus for everything. And let's just write out the factors of 25. So we have 25. We have 5, and we have 1, right? Those are all the numbers that evenly divide into 25. And then we have 4. So we're going to have 4, 2, and 1. Okay, so what we're going to do now is just list out all the possible combinations. I'm actually going to do this down below because it'll take a while. So you're going to do, so again, it's plus or minus. So 25 over 4, 25 over 2, 25 over 1, comma, 5 over 4, 5 over 2, 5 over 1, comma, 1 over 4, 1 over 2, and 1 over 1. Now, again, these are all plus or minus, right? So we can simplify all of these, but we can just, also leave it here as well. And what I would recommend doing is if you, well, actually, if you didn't have, typically you'd have this problem without the calculator. So what could you do? Well, we could simplify this, right? So we could say, all right, that's going to be plus or minus 25 over 4. Now, how do you find the real zeros? So what I would do is you could just test these either by synthetic division or by the remainder theorem. And remember, the remainder theorem would be plugging in these values and then seeing if you get a remainder of 0. If you get a remainder of 0, then it's going to be a 0 of the polynomial, or that would be the remainder from division. So therefore, that's a 0 of the polynomial. Then you could do synthetic division to go ahead and divide with one of those zeros. So once so plug it in, right, using the remainder theorem. If you get 0, then it's a 0 of the polynomial. Then use synthetic division to further divide down the problem and then either look to factoring or finding another 0 that you could keep on following the process. And some of these problems could be kind of difficult. That's what I'm saying. This could take us a while going through that problem. Typically, little power tip, typically it's going to be, 1, 2, 3. So I would look at doing plus or minus 1 first, then doing plus or minus 5, looking at those zeros first. And then try to look, as once you get something that's factorable, then just kind of go from there. But you're just going to want to plug them in. If you have a graphing calculator, I would graph it and find the rational zeros that way, if possible. But at least the rational zero test will give you what is going to be a possible rational zeros from the start. All right. Question number 4 says, simplify, I think. So we're going to want to make sure we know the unit circle here. Couple things. We want to make sure we know. So we got there. So let's actually bring this down. All right, make sure we have our points here. So this is going to be 1/2 square root of 3 over 2. Square root of 2 over 2, comma square root of 2 over 2, and then we have square root of 3 over 2, comma 1/2. Okay, just remember, guys, this can be rewritten as 5 cosine of 60 degrees squared plus 4 secant of 30 degrees quantity squared minus tangent of 45 degrees quantity squared. So it's easier to write this squared thing, but I want you to understand, that's what that value means. These, when I say cosine squared of 60 degrees, that means cosine 60 degrees squared. Okay, that's just our notation. All right. Now, maybe we could also look at this and identify this to be our Pythagorean identity, maybe, right? Sine squared of something plus cosine squared of something equals 1. But just for the sake of having some fun, I'm pretty sure that answer is going to be 1 using the Pythagorean identity, but we'll still go ahead and plug it in just for fun and to make sure that that Pythagorean identity is true. Okay, that's a squared. All right, well now, if we use a Pythagorean identity, all we're simply going to do is just plug in our values. So cosine of 60, remember cosine is for coordinates on the unit circle. These are x and these are y, right? So cosine is going to represent the x coordinate. So here is 60 degrees. This is 45 degrees, and that's 30 degrees. So remember, cosine is x. Cosine of an angle equals x. I don't know why I'm teaching so much on this. Spending some time going on. So sine of an angle is y. Tangent of angle is y over x. And this is for points that are on the unit circle. So cosine of 60 degrees is going to be 1/2. So we'll have 5 times 1/2. And remember, that's quantity squared. Plus 4 times secant, that's going to be 1 over x. That's going to be of 30 degrees. So that's going to be 1 over 1/2 quantity squared. And then minus tangent of 45 degrees. Well, if you take one quantity divided by the other quantity, that's going to equal 1. So that would be 1 quantity squared. So 1 divided by 1/2, and that's all going to be, let's see, sine of 30 degrees. 30 degrees, that's going to be square root of 3 over 2. Quantity squared plus 1/2. Quantity squared. All right, so let's see here. We get 5 times 1/4 plus, let's see, 1 divided by 1/2. So divided by 1/2 is the same thing as multiplying by 2. So that's going to be 2. 2 squared is 4. 4 times 4 is 16. Minus 1. Sine of 30 degrees. Yeah, it's 1/2. Oh, it's cosine. I'm an idiot. Did anybody check it out? Hi, Nancy. You caught me right at a good time. I got you right in there. Anybody see my messages? Yes, Brian, I can see your messages too. But I am not able to see as many of your guys' stuff. All right. So that is the sine, cosine of 60 degrees. Oh, cosine of 60 degrees. Yeah, I did have it right. So that's 1/2. All right. So, and then if you get this, you'd get a 3 over 4 plus 1 over 4. And you can see how that would become 4/4. So let's kind of move to the right. So this is going to be a 5/4 plus 15 equals 4 over 4, which is just 1. So we'd have a 5/4 plus 15. If you're going to put 15 over 4, that would be a 60/4. I don't know why that's 5/4. That's really weird. So 5/4 plus a 60/4, which is equal to 15. So that equals a 65/4. Sorry for going down, right, and down. That's just my area that I had. The next question says, wow, I got to keep moving. Find the area of the equilateral triangle that has a height of 25 inches. So we know that equilateral triangle is going to have sides that are all the same, right? Okay, so it has a height of 25. Now, if it 25 inches. Okay, and this kind of plays into the trig as well. If we know this is 60 degrees, and now I just had this bisector, then we know that's going to be 30 degrees. And I would recommend knowing your special right triangles, because that's going to be the easiest way to be able to understand this. So if you have special right triangles, this is going to be your, let's actually do a regular relationship here. So our special right triangles here is going to be my short leg, my hypotenuse, and my long leg. So that's the relationship between the two. So to go from my short leg to my hypotenuse, I multiply by 2. And again, this is for every 30, 60, 90 triangle. Every 30, 60, 90 triangle has this relationship amongst its sides. That's why it's a special right triangle. So to go from my short leg to my hypotenuse, I multiply by 2. To go from my hypotenuse to my short leg, I would divide by 2. That's okay, Addie. Thank you so much for showing up. I really appreciate it. To go from my short leg to my long leg, you would multiply by square root of 3. So to go from my long leg to my short leg, you're going to divide by 3. So this would be a 25 divided by the square root of 3. Now, if I'm trying to find the area, I'm just going to leave it like that. And then notice, guys, if I have this bisector, right, this angle and line bisector, that means this is going to be 25 over square root of 3 as well. Okay? So all I need for an area of a triangle is going to be 1/2 base times height. So I'm going to have 1/2. The base is going to be 2 times 25 over the square root of 3, right? Because there's 2 of them. And then 1/2 base times height, and then times 25. Oh, base is, oh, what was I doing? There's not extra 2 there. So it's 1/2 base times my height, which is 25. And that's going to be some big number. I don't know if you need a decimal or whatever else, but we'll leave it at that. Well, hello. Well, thank you. I like that name. Nick's Music. Happy to help. Simplify the expression. Show a rationalized denominator. Well, thank you, Emily, for spicing up my Sunday evening here. All right, this has a lot of radicals. But again, like the process, guys, is going to be the same. When you're multiplying, when you're completing the, remember, started my sentence like 5 different times. When we're rationalizing the denominator, we need to understand that all of our radicals, our even radicals, are going to have their conjugate, right? So whenever we have the negative 4 square root of 7, we're going to have positive square root of 4 to 7. So we're going to want to multiply by this conjugate. So we have the square root of 14 plus 4 square root of 7. And you're going to need to multiply that on the top and the bottom. Plus Okay, so now we need to distribute on top, and then the cool thing about multiplying, well, the cool thing about multiplying by the conjugates is this creates a difference of two squares. So the math is a little bit easier in this case. Remember when you're multiplying radicals that you can just multiply your radicands. So in this case, I'm going to have, all right, so I have 3 and 7 times 14. So 7 times 10 is going to be 70. 7 times 4 is going to be 28. So that'd be a 98. Oh, geez. I have to simplify this. 89. I guess that doesn't work in for there. 16. I think I might have lucked out. Yeah, because it's the even divided by 2, but it won't work from that case. Let's see what they have. Yeah. Wait a minute. Oh, dang it. Yeah, 49, okay. And then here we'd have 12. And then we'd have square root of, so square root of 7 times square root of 7 is square root of 7 squared, which is going to be times 7. Okay, and then down below, we'd have square root of 14 times square root of 14, which is going to be 14. Negative 4 times positive 4 is a negative 16 times 7. The square root of 98, that can be simplified into 49 times 2, which is 7. So 3 over 7 times the square root of 2 plus 12 times 7, which is, again, positive 98 in this case, all over a 16 times 7. So 10 times 7, again, is 70. And then 6 times 7 is going to be a 42. So therefore, that's going to be 70. That's going to be 12. That's going to be 112. And then minus 14 is a negative 98. Hopefully check my math. I don't know. You guys are making me, I do not like doing mental math in front of people. That's not something that's very fun to do. All right, good. I did all right. And then, so here we'll have a 21 square root of 2 plus 98 divided by negative 98. And then I think we're going to be good. Oh, wait, no, I can probably factor out a 7, right? Oh, jeez. Dang it. Okay. So if you divide everything by 7 here, we get a 3 square root of 2. That would be plus 14 divided by negative 14. Whew. All right. We'll go ahead and simplify and that result reduce. But thank you, Emily, for, man, that was not what I was expecting. All right, Shreya, thank you so much for bringing me a question that is very simple. So a good one just to slow down on the algebraic process, right? It's not a very difficult problem. It's just, a lot of mental math and simplifying and a lot of things that were going on just for one simple problem. Rationalizing the denominator is fairly simple, but obviously you can see this took on multiple steps. So the nice thing about dealing with fractions is really you can deal, you just add and subtract the numerator or the denominator as long as you have common denominators. So in here, you can see my denominator is 3. So therefore, I can just add the numerator. So I apply the operation to the numerator, keep the denominator the same. So this gives me a 6 over 3. And then 3 evenly divides a 6 2 times. So if they don't have the common denominator, you have to find the smallest number that both of your denominators divide into. So if you have trouble with that, you can just list out the multiples. 2, 4, 6, 8. Who do we appreciate, right? Just keep on going. 3, 6, 9, 12, 15, 18. Just list them all out. And then hopefully you can see that, oh, the smallest number that they both divide into, right, that they share as a multiple is 6. So that's what we call our least common multiple or our least common denominator. And then what we need to do is we need to obtain that. So therefore, we can apply the operation to the numerator. So I can multiply by 3 on the left-hand side and right, and a 2 on the right-hand side. So I get a 3 over 6 minus a 2 over 6. And that leaves me with a 1 over 6. So again, obtain the common denominator, and then you apply the operation to the numerators. All right. The next question comes in from, I actually don't remember, but it says suppose a differential function fx has the first derivative, f prime of x equals sine of x minus cosine of 2x. Find the critical numbers of the function on the interval 0 to 2 pi. It's been a while since I did the calculus, and that's why I usually do not like doing calculus problems, just because my instruction and my delivery is not, I'm not teaching calculus here. So I feel like my explanations are not going to be perfectly on point. And so I did receive actually quite a bit of calculus problems. So if you submit a question and I didn't get to it, that's probably the reason why. I looked at it and I was like, I can work through the problem, but I'm like, as far as like the explanation, I don't want to give you a half explanation or a poor explanation. But for at least on this one, we know that the critical numbers, that is going to be, that's going to be when my derivative is equal to 0. So at least with this one, I saw the trig and I'm like, well, I've been doing a lot of trig. And this one actually looks like a pretty fun problem to solve because I immediately saw my double angle formula and I'm like, oh, this is going to give me a quadratic. This is a good problem. A lot of students have trouble with this. So the nice thing is we're trying to find the critical numbers, right? That's going to be when the horizontal tangent is going to be, we're going to have a horizontal tangent, meaning we're changing from increasing to decreasing, right? So therefore my derivative is going to equal to 0. So what I'm going to do is I'm going to set my first derivative equal to 0 minus the cosine of 2x, okay? And then what I'm going to do is I'm going to replace this with my double angle formula. Make sure you're using your parentheses. And again, that's kind of important. Actually, this is really important to, what's his name? Brandon, because if you don't include parentheses, right, you would have -1. But again, like you need to distribute this. So it's really important to use those grouping symbols, which I kind of talked about before, to kind of understand this problem. Sine of x -1 plus a 2 sine squared of x. Now, if you had the equation that looked like this, x minus 1 plus a 2x squared, you would recognize, oh, that's a quadratic, right? And quadratics, you put them in your standard form, right? 2x squared plus x minus 1, and then you try to factor them or using the quadratic formula. Well, that's the same thing even with trigonometric functions, guys. So we have a 2 sine squared of x plus the sine of x minus 1. We're going to want to see if this is factorable. All right, so to look if it's factorable, I'm going to go to a quadratic equation in terms of x and see what I could factor, right? Because for me, it's a little bit easier to factor a quadratic with variables than it is to factor with trigonometric equation or trigonometric functions. So I know here it's going to be 2x and x. I know to get a -1, that's going to be a -1 and a +1, right? One of them is positive, one of them is negative. My middle term is positive, so that means the larger of my two products with 2. So 2x times 1 or x times 1 or -1 has to, whatever, the larger one has to be positive. So that's going to be a 2x plus 1 or 2x times +1, right? Because when you do FOIL, that's going to multiply. And that'd be the negative. That's going to be my smaller product, right? Because we know the first two terms, 2x times x gives us 2x squared. We know the last term gives us -1. These middle ones are going to add to give us our x, and that works. So I'm just going to copy this, but I'm just going to use sine instead of x, or sine of x instead of x. 2x minus 1, and then this would be a sine of x plus 1. And voila. So now what we can do is apply the zero product property, right? We have the product equal to 0. So now we can set them both equal to 0. And then we can say, oops, what happened to my 1? Oops. Okay, so now you can say the sine of x equals 1/2. Sine of x equals -1. Okay, so now via the unit circle, we can say, all right, well, when is sine of x going to equal 1/2? And when is sine of x going to equal -1? Well, it's actually, we need to go a little bit more than the unit circle, actually, or the first quadrant. We need to actually look outside of that. Okay, so within the first quadrant, we know sine is equal to 1/2 at this angle, right? Which is going to be, let's go and use our radians. That's going to be at pi/6. But we also know it's going to be over here, right? And that is going to have the same reference angle. So that angle is also going to be pi/6 away, but so therefore the angle is going to be 5 pi/6. So my solution set here, did this say, oh, in the interval 0 to 2 pi. Okay, so we'll have pi/6 and 5 pi/6. And then the only time where sine is equal to a -1 is going to be down, no, negative, yeah, y coordinate is -1, right? Because this coordinate is 0, -1. So that angle, if you remember on the y-axis, is is 3 pi/2. Brian, watch yourself. Don't want to get bumped out, but thank you so much. Yes. All right. Question number 9, it says a line through -1b and c, 8 is parallel to the line through -6, 3 and 0, 12. Find the values of b and c that make the statement true. Okay, so if we know they're parallel, then we're going to have the same slope, right? Same slope. Okay, so let's go ahead and find the slope here. So let's call this a and b. Or let's just call, whatever, to a line. So let's just call this line A, and let's call this line B. All right? So the slope of line A is going to be, remember slope, guys, is m equals y2 minus y1 over x2 minus x1. All right? So it's going to be change in y over the change of x. So we're going to have 12 minus 3 divided by 0 minus a -6. Again, using my parentheses, right? Because it's minus a negative. So that means it's going to be a positive. So we're going to get a 9 over a positive 6, which is going to equal to 3/2. Okay, so I need to get a 3/2. So for the slope of B, slope of B is going to be a 8 minus B all over a C minus a -1. That needs to equal a 3/2. So I'm assuming if I just need to solve for B and C, well, if 8 minus b needs to equal 3 and c minus a -1 equals 2, why don't I just set up an equation for both of those to solve? So again, that's a b, not a 6. I'm sorry, I have really bad b's. And I never knew that you're supposed to draw your 6s like this, I guess. I always draw my 6s like that. I guess I failed, I don't know, first grade or something. So let's go ahead and solve. So it's 8 minus 6. No, it's c. Sorry, guys. This is why I was always, we don't really use b that often. But I remember in like Algebra 1 when I used to teach it, students, like when Algebra 1, we use a lot of different variables and we use b a lot. So I feel bad for the students because I probably confuse them all the time. So now let's go and solve for b and solve for c. So in this case, we can just subtract the 8. So negative b equals -5. Divide by -1. b equals +5. Here, that simplifies to c plus 1 equals 2. Subtract 1, c equals 1. And there you go. Ian asked for, he just said hyperbola and then gave me an equation. So I'm not really sure what he wanted. I'm assuming probably graph it and find the parts. So it doesn't really look that fun, but I will find the parts and maybe just do a random sketch. So when we have a hyperbola, remember it's in the form of, or this form here, it's going to be x minus h quantity squared all over a squared minus y minus k quantity squared all over b squared equals 1. Okay? So remember, a represents the distance from the center to your vertices, b represents the distance from your center to your co-vertices, and c, which represents the distance from your center to your foci, is going to be the sum of a squared plus b squared. So it's kind of a squared plus b squared. Easy way to remember it is kind of like the Pythagorean theorem, right? And so typically, first thing we want to do is actually figure out, sorry, it's c squared, is let's figure out what c is. So therefore, that's going to be a 18 plus a 32. So c squared equals 40. That's going to be a 50. And therefore, c is going to equal the square root of 50, which is equal to 25 times 2, which equals a 5 radical 2. Okay. What am I trying to do? Oh, I think find the center. And that's going to be 0, 0. That's going to be your h and your k. Typically, we want to identify the vertices and the foci. At least that's what I'll do. And then probably asymptotes as well. Well, that's kind of weird. I just like dropped everybody. I just like looked at my stream and it says nobody's on. So that's kind of weird. So I guess if you're still on the stream, maybe make sure you let me know that you're in on the chat. That's kind of weird. It says I have an excellent connection. That's just kind of funny. All right. So to identify the foci as well as the vertices, there we go. Looks like everybody's back in. We need to identify what we call the transverse axis, and that's going to be the axis that those lie on. So since my a squared is under my x, we're going to have a horizontal transverse axis. And this is important because when you're looking at the graph, right, so we have 0, 0, the foci and the vertices are going to be going left and right. So the foci are going to be, the vertices are going to be a distance away. So if a squared equals 18, then a is going to equal the square root of 18, which I've already broken this down, so I'm not going to do this one, which is going to be, now I'll just do it, whatever, 9 times 2. So a is going to equal 3 times the square root of 2. So the vertices is going to be plus or minus, right, because you're going to go to the right and to the left of 3 square root of 2. So it's going to be plus or minus 3 square root of 2, comma 0. Again, we're going left and right. So since they are not, since I'm not doing a direct thing, we can see that's the distance. My foci are also going to be left and right, but these are going to be a plus or minus 5 square root of 2, comma 0. Foci, foci. And then you could do the covertices, but hopefully you just kind of like recognize the graph's going to look something like, actually, you know what, to really graph it, let's go ahead and find the asymptotes. And if I remember correctly, the asymptote is y equals plus or minus b over a times x minus h plus k. So b, in this case, dang it. So b squared is 32. B equals the square root of 32. So b is equal to 16 times 2. So b equals 4 square root of 2. I'm like sneaking in a lot of work here. So that would be plus or minus the 4 square root of 2 all over a, which is 3 square root of 2, times x minus 0 plus 0. All right, so that can simplify to a plus or minus a 4/3 x. So we're going to have an asymptote probably like that, and an asymptote like that. And again, remember the graph approaches those asymptotes. So there you go. Nice little sketch I got for you. The next question comes in from James. He said, give me a shout out. James, here is your shout out. He also said he submitted this question before, but I didn't answer it. And again, guys, I cannot guarantee I can get to your questions. I actually had a huge backlog last week. And so thankfully I was able to get to, I wasn't able to get to everybody. I wrote down a lot of questions. We only have 2 more to go. But yeah, so, I apologize. But also, James, you submitted 6 questions into me. So I'm not sure which question you wanted me to get to or what you really were expecting. You can see how this has already been a pretty long stream just by me going through questions. So, it's always helpful, guys, if you are very detailed and direct in what you want me to help you with, as well as if you just kind of keep it simple for those questions. But I will try to do my best to get you guys. I'm not sure which there's 3 more that he added, and then there's another one, and I just decided I like this question. So I was like, you know what, I'm going to do this one. So it says solve the equation to find the length of the longest side, which is going to be the hypotenuse. So, but either way, we need to find x. And hopefully you guys recognize this Pythagorean relationship here, a squared plus b squared equals c squared. So I was like, that doesn't sound like fun to square all of those, but it's like, you know what, why don't we just do it? So 14. And then see what happens. Okay. All right. So I've never done a problem like this. So remember, the nice thing about having a binomial squared, hopefully, is you square the first numbers, you double, and you double the middle number. So times the first term. So multiply the first term times the second terms, and then times it by 2. So this is going to be a negative 28x. And then you square the last term. So 14 times 14 is a positive 196, as I recall. So here, this would be x squared plus 2x plus 1. All right. So now, all we simply need to do is get all of our values to the same side. So hopefully you see that, let's see, subtract an x squared. So I get a x squared, and I can subtract a 2x, subtract a 2x, so x squared minus 30x. Subtract a 1, 30x plus 195 equals 0. All right, and then from there, you would go ahead and solve. But since I'm a little bit late in time, factoring, let's just kind of play around with some numbers. I just want to kind of see. Maybe it is something easy. It does go into there. No. It doesn't look like that's going to be factorable because it's going to be 2 numbers that are going to add to give you 30. And I just did 15 and 13. And that gives you 28. So it looks like you're going to have to, unless I did something wrong. Not seeing anything wrong I did. That'd be 2x minus 1. That's a negative 30x. But yeah, then you just go ahead and solve and then plug back in. So hopefully at least that gets you up, James. Hopefully that helps you out. Thank you so much for joining the stream. I'm sorry I couldn't get to all of your questions. Same thing with sequences and series. You know, I get to those. Well, thank you, Mike. I cheated on my test. Well, I appreciate you being honest on the live stream, and I really do appreciate the super chat for that. And I hopefully that my videos have been able to help you. I guess maybe not so much cheat, but at least get you there. So I appreciate it. All right. Well, happy to help you, Connor, as well. So yeah, just go ahead and, solve from there and go ahead and plug it in. All right. Whoa. Oh, I didn't bring your room. Oh, I guess I could delete that. Okay. The next question comes from Kuya, I believe, is find the intercepts of the following rational functions. So the cool thing about the intercepts is I think Kuya, I remember added some comment I don't remember. So here's something that everybody should remember. It doesn't matter if you're in Algebra 1, if you're in Calculus. Remember, guys, that the x-intercept is when y equals 0. The y-intercept is when x equals 0. So if you get stuck, you don't know what the function looks like, you need to find the intercepts, you can always rely back on that, right? The x-intercept is when y is equal to 0. And again, it makes sense, guys. X-intercept, where across the x-axis is when y is equal to 0, right? Here's the x-axis, here's the y-axis. Y equals 0, right? There's no height. It's on that y. It's on that x-axis. Same thing. The y-intercept, x equals 0. There's no left or right. Okay, so it doesn't matter what the function is. You can prove the values. Now, there's something really cool though that happens when I am finding the x and y intercepts for rational functions. We can actually do this a little bit quicker. So the x-intercept is when y is equal to 0. Well, y, same thing as f of x. So 0 equals x squared minus 7x plus 12 divided by x squared minus 5x plus 4. Okay, so the first thing, and when you need to solve for x, you can't solve for x when it's in the denominator. So the first thing you're going to do is multiply the denominator on both sides. And I want you guys to see something. When you multiply by the denominator, on the right-hand side, you're multiplying by itself, right? So that's always going to go to 1. On the left-hand side, you're multiplying by 0, so that's going to always go to 0. So guys, it doesn't matter what you're multiplying by. It doesn't matter what your denominator is, right? This could be 4 raised to the x, cosine squared. It doesn't matter what's in this denominator because when you multiply it by itself, it's going to go to 1, and when you multiply it by 0, it's going to go to 0. So the trick, or simplified here, is when you are trying to find the x-intercepts, just set your numerator equal to 0. So you get an x squared minus 7x plus 12. And now we got to figure out what two numbers multiplied to give you positive 12, add to give you a negative 4. That's going to be x minus 4 times x minus 3. So therefore, now you can apply the zero product property. So you could say x minus 4 equals 0, x minus 3 equals 0. So you could say x equals 4 and x equals 3. Okay. So now let's do the y-intercept. So again, the y-intercept is when x equals 0, right? So again, you're just going to plug in 0 for x. So I have f of x equals 0 squared minus 7 times 0 plus 12 all over 0 squared minus 5 times 0 plus 4. Now the cool thing is, guys, wherever there's an x, that's always going to go to 0, right? So the So what's happening here is it doesn't matter what you have. All you're simply doing is taking the constant over the constant because everything with x is going to go ahead and just go to 0 anyways. So you can see in this case, we're just going to have our y coordinate, or f of x, is just going to equal 12 over 4, which is equal to 3. So y is equal to 3 is going to be the y-intercept. Logan, when you're ready, I appreciate it. That seems like a pretty difficult problem for me to be able to read and go ahead and set up. But Logan, if you want to go ahead and submit your question, I do take questions in my Google form. Unfortunately, I am at the kind of ending point of my live stream. So I'm not really going to have time to set up your problem, but I do appreciate you typing in everything to get to me. But yeah, I do have a Google form where you can take a picture or retype it in, and then I can go for that on this next stream. But I will have to end off on question number 13, which was graphing the inequality. So when we're graphing a absolute value inequality, the main thing we need to do is isolate the inequality first, okay? So don't treat this as a parentheses. What we're going to need to do now is isolate it. So we have a 3/5 absolute value of 5z plus 2. And that's going to be less than or equal to a 6z plus 12. Now we're going to multiply by a 5/3. And again, need to insert parentheses, right? Because you're multiplying both of them times 5/3. I've actually never had to talk about using my parentheses so often after that student asked me about them. So we have 5z plus 2 is less than or equal to, let's see, this is going to be a 30 divided by 3. So 30 and then divided by 3 is going to be a 10z. And then 5 times 12 is going to be 60, divided by 3 is going to be a 20. Okay, so now once we have a inequality, now what we can do is use what we call our two cases, right? Because again, like if I say the absolute value of x equals 4, we know x equals 2 or x could equal -2, right? So what we want to do, even if it's an inequality, is we want to make sure that we can understand that we need to make sure we take in part into both cases, right? So x equal 2 or x could equal what am I doing? Jesus. X could equal 4 or x could equal -4. So we need to take into consideration the positive as well as the negative case. So to do that, the first case is just going to be as it is without the absolute value. So 5z plus 2, I'll write my 2's like that, is less than or equal to 10z plus 20. Now, for the negating one, we got to kind of think about this is, you could also like make this negative and then divide by negative, and that would flip the sign. But an easy way just to remember is, yeah, when you negate, you're going to, flip the sign. So therefore, the other case is going to be a 5z plus 2 is greater than or equal to 10z plus 20. Or sorry, we need to negate that side. If you're going to flip the sign, it needs to be negated. So that'd be a negative, what am I doing? Negative 10z, and then plus 20. Okay, so now you can distribute that, and then you'd have a 5z plus 2 is greater than or equal to a negative 10z minus 20. Okay, so now we just basically need to solve and then go ahead and graph. So first thing I'm going to want to do is get my variables to the same side. So I'll subtract a negative 10z. I'll subtract a 2 here, so I have a negative 5z is less than or equal to 18. Divide by -5, divide by -5. Remember to flip the sign, so z is going to be greater than or equal to a negative 18/5. Doesn't seem a little fun to graph, but we'll be able to do it. That's a 2. Man, my 2's look like z's. See how I put that line in there? Well, thank you, Adrian. Happy to help you out. Make sure you're careful with those. I flipped the sign, right? Yeah, okay. All right, so in this case, I'm going to add a 10z and subtract a 2. So I have a 15z is greater than or equal to a negative 22. Now I'll divide by 15, and you can see a z is going to be greater than or equal to a negative 22 over 15. Okay, so that's going to be roughly like 1 point something, right? That's like 1 and 7/15. Right, so 7, yeah, so 7/15, like 1.5, right? So roughly, let's just say like 1.4, okay, approximately. And then this, you can see that it almost goes in like 3 times, and then it's gonna be 1/5. So 3.2. Okay, so now I'm just gonna go ahead and graph. And again, I just wanted to give you guys those approximations. Actually, I don't want to like confuse you because this mathematically has nothing really to do with that. That's just for our understanding of those numbers, okay? But that's really about it. Okay, so if we're going to graph the inequality, we're going to have here's 0, and then let's say, you know, like -1, -2, -3, -4. Okay, so it says z is greater than or equal to -3.2. So there, and that's going to be going that way. And then z is going to be greater than or equal to, yeah, because that got flipped, -1.4. So unless I did any work right, what we're looking for is the intersection of these two graphs, which is only going to be when z is greater than or equal to -1.4. But again, we probably need to check our answers on this and go ahead and plug them back in to make sure that they are going to satisfy our inequality. So let's go ahead and do that real quick. Man, why you give me these problems? All right, so I'm just going to do a mental check because my brain hurts now. So that's going to be -18 plus 2 is a -16. Absolute value of 16 is going to be, Brian, we see it. Triangle summit. It's inequality, not quadratic. Huh? It's an inequality, not quadratic. What? Are you guys talking to me? I'm not really sure. It's inequality, not a quadratic. I'm not really sure what that was. Okay. Well, either way, I would just go from this. I would just double check my answers, make sure that my inequality is going to work. It's an inequality. Even I've never been the teacher of the year. Thank you. I was nominated this year though. But either way, guys, I'm just going to end it on that. I'm not seeing the solution. You'd probably want to go back and check the answers from on there. No, it's quadratic. I'm not. You guys must have a conversation. Either way, I don't know, guys. It's 10:09. I am exhausted tonight, but I'm just going to end it off on that problem. We'll just say that here is going to be my solution from on that, and then we'll just go from there. But I'll just have to go and leave it when I have from there. So otherwise, guys, I'm sorry I'm not going to be able to get to any more of your questions. But if you guys do have more questions, feel free to add them into the Google chat or into the description in description of the stream. And therefore, I will look forward to seeing you guys back here again next week at 9 p.m. Eastern Standard Time. Well, I'll answer your questions and help you guys along with your year. So, all right, guys, have a great evening, day, morning, and I will see you guys next week. All right, cheers.